Welcome to today's presentation, Migrating to the Cloud with Chef and AWS. Let's go ahead and get started. Nat, why don't you kick us off by telling our audience what we'll be covering here today?
All right, thanks, Jamie, and hello, everyone from downtown Seattle here. And if you hear some of the extraneous sounds of the city, we're apologizing in advance. But part of the great thing with our offices being where they are is that we get all the fun of the city and the associated noises. So we're going to hope that that's not too much of a problem. But we're going to get going here with this webinar. So today's very exciting because when we think about what's going on with digital transformations and the move to the cloud and AWS, it's really an exciting time for companies to be able to think about not only how do you save money, but how do you start really taking advantage of the innovation that Amazon and AWS is driving here. And so in today's presentation, we're going to go through an overview of what's involved in a cloud migration, just kind of summarize what some of the benefits are that they're the obvious and sort of the hidden benefits of cloud migration, and also some of the feedback we get from our customers in terms of challenges that people are seeing in terms of how are they successfully moving to the cloud and some of the barriers that they encounter. In this, we're then going to move to talking a little bit about how Chef thinks about migration. In particular, we'll be focusing on how Chef can support customers that are moving to Amazon Web Services. So for this, we're going to give everybody a bit of a grounding in terms of what are the types of migration, and also how does Amazon look at managing migration in terms of what their responsibilities are and what they ask the customers to do. Then we're going to move to Nick Rykar is going to go and really talk about some of the patterns that we see for successful cloud migrations. He's going to give an awesome demo of showing how you can move a workload from a kind of a traditional on-prem infrastructure into AWS. And then afterwards, we're going to have a good chunk of time to really kind of review what we've looked at and also open up the floor for questions from the attendees here. So very quickly, in case you're not familiar with Chef, I want to give everybody a bit of an overview about who we are and what our background is. Chef's, our history is really about being one of the innovators and the founders of the Agile Lead, in particular the DevOps movement. One of the things that's important to who we are and how we operate is that our foundation is from an open source perspective. All of our key technologies around Chef, Inspec, and Habitat are built from an open source perspective, and so we really believe in that transparency and the vibrancy of not only the open source movement, but what the community brings to the table in terms of driving success and innovation here. We have tens of millions of machines that are under management with Chef and Chef Automate, and the company is a global company. Outside of our Seattle group, we've got offices in San Francisco, London, Berlin, and about 265 employees around the world. We are in 70% of the Fortune 500. We've got companies that are using Chef to really drive digital transformation, from cloud first, born in the cloud type startups, people like Facebook and so on, into manufacturing, transportation, and so on. Really some of the biggest and the brightest of the industry are using Chef right now, which gives us a lot of fantastic feedback from our customers that allow us to go and get the right kind of insight to drive our products forward to help you serve your transformation in the best way possible. Just to get some information now as a level set for our conversation, I'm curious of the folks on the webinar here, when are you planning to migrate to the cloud? And then you'll see that there's a number of answers here. I'd love to have you fill out where you are right now, whether you're all in on the cloud today, whether you're in a hybrid state where you've moved some of the workloads to the cloud, where you may have a migration pilot where you're looking at kind of getting your feet wet with the cloud, or are you in the planning process of migration? Do you have no firm plans to migrate yet? Whichever one of the things you see right now, if you could answer this, I'd love to get some feedback here so that we can look at where the crowd is today and make sure that we tailor the content accordingly. And so we'll give a few minutes here for the answers to come through the system. And yeah, it's been a very fun time for me at Chef, because as we're talking to customers, we're really getting a good sense of how people are thinking about the cloud, but really, I think most importantly, where they see some of the challenges and the opportunities lie. And so as we get the results here, that this mirrors a lot of what we've seen today, where, I think it was Andy Jassy from Amazon at reInvent last year was one of his big takeaway points is that hybrid is the new reality. And you see right now, 41.9% of the people, move some workloads to the cloud. And so this is a very typical reality where as you move some workloads to the cloud, you kind of have 1 foot in your legacy infrastructure and 1 foot in the cloud. And that kind of an opportunity is a place where Chef has really put a lot of effort in making sure that you can manage your hybrid infrastructure from a single location. And this is something that Nick will show in the demo in a bit here. So again, I think this is a pretty typical distribution where just under 10% are all in. Right around 42% are in that hybrid environment, and then you see the remainder are at a place where either they're in a transition or that they have no firm plans. This really reflects the reality of what we're seeing and really underscores why cloud migration matters. It's one of those things where I think for a lot of us, if you read the industry press or you go to events, because cloud is such a front and center topic, you think that, at least I personally think that people are much more further down the path of cloud migration than they really are. But what we're seeing right now is that cloud migration is moving to the mainstream. And I think the biggest benefit from my perspective about why cloud migration matters is that the work that Amazon and people like Microsoft and Google are doing in their cloud innovation is really about looking at the innovation they're driving to run their business at this incredible scale and allowing companies of any size to benefit from this. And so that opportunity to share in the innovation is really a great way to move your business forward and benefit from the incredible, the billions of dollars in investment going on in engineering and scale that the large cloud providers are putting forth. Having said that, we hear a lot of feedback from different customers, both small and large, that there are some really serious barriers that are facing a company as they're starting to consider a cloud migration and put their strategy into place. Things that we frequently hear are that there's a concern about the skills gap. Do I have to learn a new set of skills to retool my team to the cloud relative to what they've learned around bare metal or VM implementations? There are concerns about the perception of risks. How do I maintain uptime on my cloud infrastructure? How do I get the right visibility into my cloud system and my hybrid system at the same time? And then last, I think there's the fear of the unknown. That when you have a data center and you can look at your hardware, there's a sense of comfort that comes from that, and you're really, putting trust into a third party that they're going to run your systems in in the same way that you would to theirs. So I think that fear of the unknown is another intangible that does color how people are thinking about moving to the cloud. But again, I think the thing I want to underscore for folks is that we are still at the early stages of cloud migration. There's a great quote here from this Morgan Stanley research where CIOs expect to see 21% of their applications move to public cloud this year and 46% by 2020. So even in the next 2 years, CIOs surveyed still are only seeing less than half of their workloads moving to the public cloud. I think it's helpful now to think about, when we talk about cloud migration, I think it's important to really unpack what cloud migration means and think about the two types of migration opportunities that Chef is hearing about from our customers. The first one being infrastructure-centric, and the second one being application-centric. And with Chef, we've built out our offerings both in terms of Chef Automate as well as our Habitat development product so that we can help customers automate and address these two types of migrations. I think one of the things that's very important to think about here when you're planning your own migration is that when you're moving to AWS, you're typically going to start off thinking about, if I move my environment wholesale into the AWS cloud, I can start saving money both in terms of hard costs on my servers, but also having some of my management tasks offloaded to AWS. But this is just really the start of the journey and not the end of a journey from cloud migration. The second thing that I think is really important to think about is when you look at application-centric move to a cloud-native infrastructure, you can really start benefiting from what the architectural changes are that are present in a cloud-based environment. And this is really interesting where after you get your applications moved to the cloud, you can then start thinking about looking at containers, looking at microservices or serverless architectures, to start taking advantage of the architectural benefits and innovation that's being driven by the cloud vendors. So as you think about this, I really encourage you to think about the long-term journey you're looking at, but not get daunted by trying to do it all at once, but looking at a staged implementation that will allow you to think about that in a way which is more manageable based on your business and your objectives. So the next question I want to ask folks is, what types of cloud migration are you currently planning? Are you looking at infrastructure migration, application modernization, like moving to a PaaS architecture or containerization, serverless deployment, or if you have no plans yet or others? So I'd love to get folks to take a moment and answer this question so we just get a sense of what types of migrations you're currently looking at. All right, and so as these answers come in, one of the things that that has been really interesting from watching customers who are successfully moving this really looks at when you think about the role that containers, whether it's Docker or Kubernetes or something else, plays in your migration. It's kind of a good least common denominator technology to look at after you start moving workloads to the cloud, because containerization and the abstraction that it brings to the table gives you a great degree of flexibility here. So as we're seeing customers think about application modernization, that containerization of application workloads and just thinking about how it can fit into your strategy is a place that, that really shows some good benefits to folks. And so letting the data come through here. All right, so right now we're looking at 100% infrastructure migration, which is fascinating. So this is great because this is exactly what Nick's going to be talking about.
Yeah, I've got good news for folks.
We have good news for you. Before I hand over to Nick, I do want to talk about very specifically the AWS shared responsibility model, because as you're starting to move from kind of the planning into the pilot phase around the shared responsibility model for AWS, I think it's really important to understand what's the division of responsibility for security and management that AWS handles and what, as a customer, you need to double down and focus upon. AWS has done a really good job of explaining this and articulating, I think, a really clear fashion where you can see in this diagram here, which is taken from the AWS website itself, the responsibility for security of the cloud falls to AWS. And then the responsibility for security in the cloud is the responsibility of the customer. So what's great about this is that everything you see here in yellow, compute, storage, things like security of facility and so on, that falls onto AWS. And this is a great place for you to benefit from their investment, the teams they have in place, the global security and so on, where everything there is taken care of by AWS, which then still puts the responsibility of everything above the line onto the customers. And this is where you look at customer data, you're running patch management, the configuration of permissions on your systems and so on. That still falls into the customer. And so as you're thinking about this and planning this, what Nick is about to show you is really how does Chef help you not only manage this, but also automate these processes, because we really believe that as much as the blue stuff is an important area, and it's also a non-trivial area of focus for our customer, by using some of our patterns around detect, correct, and automate, especially that last part about automating these processes on an ongoing basis, you can really look at your area of responsibility from a much more actionable standpoint, so that when you're focusing upon this, you can come up with a strategy to make sure that you are not only automating your cloud compliance and your cloud security, but at the same time, with Chef, you can still manage your on-premise assets or your VM assets, as well as your new cloud assets from a single interface to make the process easier to look at, require fewer skill acquisitions to manage the hybrid infrastructure. And so with that, I'm going to hand this over to Nick.
Right on. Thank you, Matt. And so, yeah, as Matt discussed, we'll be talking a bit about how Chef works with those above-the-line concerns and how we can take advantage of the tools the cloud offers us while still maintaining visibility into all of the things that we're doing. Now, if you've seen me present before, you may have seen this slide. Before we dive into the specifics of those cloud opportunities, it's important to start by defining the outcomes that we're looking to achieve. And at Chef, our position is that high-velocity organizations are those that are able to outperform their peers on 3 specific metrics: speed, efficiency, and risk, defined as the rate, effectiveness, and quality of our software changes, respectively. As we contemplate moving into the cloud, this becomes a valuable framing device to see how we are getting measurable benefits from that migration. And since these are all relative metrics, it's worth comparing as well how we gain from the cloud benefits in these metrics versus our on-premises methodologies. Here's a list of just a few reasons that companies might be looking to migrate to the cloud. First, the on-prem methodology for grabbing new infrastructure can often be time-consuming and costly when it comes to hardware procurement or even creation of new VMs. Whereas by contrast, in the cloud or on AWS, we can provision infrastructure on demand, greatly increasing the speed with which we can deploy. Since those AWS systems can be easily re-provisioned, we can also spend less time on maintenance tasks for long-lived systems and potentially costly deployment rollbacks, increasing the speed and efficiency with which we're able to iterate on our code. AWS also offers a variety of PaaS tools, things like S3 and RDS, that we can use to deploy our content to a managed service, rather than spend resources managing those services ourselves, which can further increase the efficiency with which we can work. And of course, this runs right back to that shared responsibility model. The underlying network infrastructure and physical access to systems are all controlled by our cloud provider, which allows us to reduce the risks that we need to manage directly. Now, this isn't a complete list, just the tip of the iceberg, of course, but even with all of these gains to be had, it's important to note that moving to the cloud is not completely without cost. So it's also worth looking at what reasons organizations might have to be hesitant of moving their infrastructure into the cloud. So what's keeping us on-prem? First and foremost, as Matt mentioned earlier, is the skills gap. And this is going to be common to any new piece of tooling that you're going to look to evaluate. We need to allocate time and resources to onboard teams to whatever new workflows our new provider gives us. Beyond that, there are a variety of predictable risks inherent to any migration project. Deployment and configuration procedures are likely going to need to be adapted to our new environment. And with that task comes the risk of us duplicating efforts, where similar configurations might have completely different workflows from one environment to another. And finally, and possibly most anxiety-inducing, are the unknown risks. How do we measure parity between environments in our configuration and security? How much effort will be required to migrate legacy applications that might not have seen any recent active development, and so forth and so on. In order to take advantages of the opportunities that AWS offers us while being mindful of the risks involved in migrating, it's important to have a way to iterate quickly without losing sight of the impact of the changes we're making. And this is where Chef comes in. Continuous automation is a practice that consists of 3 steps. First, we detect. We define the requirements of our current initiative, and then must be able to validate whether or not those requirements are met in any given environment or server. From there, we correct. Any misconfigurations or issues that we identify must be remediated. Finally, we automate. By automating these detect and correct processes, we ensure not only that we can easily validate whether or not we've successfully solved the issues we've identified, but also, as we solve those issues, they remain solved going forward, allowing us to focus our efforts on future automation instead of spending time resolving known issues. Now, Chef's software offerings intend to provide tools to assist us in adopting this very style of development. And as we see, it also offers built-in integrations with cloud-native tools so we can make the most of the opportunities AWS provides us. To illustrate this, today I'm going to be taking on the role of an administrator at the fictional organization Planet Express. We're going to see how we can set targets that need to be met in our cloud migration and how Chef's software can help us achieve them. With that in mind, we're going to take a look at how we can apply that detect, correct, automate methodology outlined earlier to help us plan our migration. And that brings us to step one, detect. Now, for my Planet Express app, I know that it consists of a few discrete components that need to be installed and properly configured in order for our application to function. Before we tackle any deployment tasks, we need to be able to validate that these components are properly configured, and Chef Inspec allows us to do just that. Inspec is a tool that provides an easy-to-learn language for articulating our expectations, which can then be used to audit our systems and report back on whether or not those expectations are met. Once we've defined the problems that we need to solve, we can move on to correct and start preparing our remediations. Chef is a tool that allows us to apply those configurations to the systems we manage continuously and dynamically. As opposed to traditional scripting languages, Chef's resources are built with a native test and repair behavior, which means that it only takes actions if our systems don't already match our desired state. This further means that we can solve configuration drift automatically without making any unnecessary changes to machines that are properly configured. You may note at this point that we defined that automate step as ensuring our detections and corrections are applied automatically. The advantage to using tools like Inspec and Chef is that once we've created our policies, we've already automated that process because of that repeatable nature described earlier. This means that from here, we can move on to solving new problems and build on our existing automation. And at Planet Express, we intend to do just that. In particular, we'd like to improve our security standards as part of this migration. At present, we've done some informal security audits and ad hoc hardening on our systems, but the process for doing so is never well defined or documented. In future, we'd like to do regular audits against a formal baseline, and we've identified the CIS benchmarks defined by the Center for Internet Security as a good starting off point. Thankfully for us, Chef Automate provides some pre-built Inspec profiles, in particular those for validating levels 1 and 2 of the CIS benchmarks. Ooh, benchmarks, there we go. And so we'd like to apply that to the servers we manage. My expectation isn't that even our existing systems are going to satisfy all of CIS's requirements, but my hope is that it will allow me to see where my newly launched instances differ so that I can first bring them in line with my already hardened on-premises systems. And then we can prioritize future development for the environments as a whole. And with that, I'm going to go ahead and get my screen share ready so we can take a look at my environment. Alrighty. I'll give just a moment, since I know there's a little bit of lag when I hit share screen. But once it's coming through, what we should see now is my Prod 1 machine running the Planet Express app. So this is my first guinea pig. It's a machine in my production environment that I'd like to start reviewing against the requirements that we defined on that detect slide. Once I can validate that, I can confirm that it is indeed configured as I expect. Since Inspec doesn't change any of the configurations of our systems, it's just querying them for their state, it's safe to run this even against my production server. Now, I've also started familiarizing myself with AWS. Below, we can see that I've spun up a new EC2 instance. And this was built off of one of the stock Ubuntu images Canonical has published in the AWS Marketplace. We can use this as our control case. Since I haven't actually deployed my site to this instance, my expectation is if I run that same set of controls against this newly created machine, they should fail. And so that I can confirm that my audits are working as I expect them to. To help us accomplish this, we're going to have a look at Chef Automate. And as you can see here, there's not much going on yet. But this is where we're going to be able to get feedback on those validations we're looking to apply to our systems. It's going to give us a high-level summary of the health of my environment as a whole, as well as filterable node-by-node and rule-by-rule feedback on each system we manage. To start, we're going to go to the Compliance tab. Now, before we can get any data, we have to tell Automate about the nodes that we'd like to scan. This scanner area here allows me to define nodes and create jobs to run against those nodes. We'll start by adding my prod1 instance. I would like to connect to it over SSH, although you'll see here we have the option to connect over WinRM as well for Windows systems. And once this node is added, I can go ahead and also add my newly created Amazon instance, or I'll just go ahead and copy that public DNS name that was provided. Again, same process, define my node, define which credentials I'd like to use, and I've already loaded my SSH keys here. And now we have the ability to create a job to scan our nodes. Clicking this Add Job button lets me select the nodes that I'd like to apply my audits to and the inspect profiles that I'd like to use. And I've preloaded this Planet Express validator that we'll take a closer look at in just a second. I'll name my job, we'll call it Cloud Validate. And when we create it, we can see that our job is scheduled and should run on our system shortly. While we're waiting to check in, I can hop over to the profile store here, and we can take a closer look at what this Planet Express validator profile is actually doing. Here we can see a list of rules or controls in inspect parlance that define what we're looking to verify. You'll note that the things we're validating here match up with the list of my application components called out in the detect slide earlier. We take a look, for example, at this validate Apache rule. It's going to give us some further detail that our expectation is that Apache is installed and running. We also have the ability to look at the underlying inspect code, where I can see here what I'm making use of is the inspect service resource, which is going to look for a service named Apache 2 on my systems and set the expectation that it be installed, that it be enabled, in other words, that if this machine reboots, Apache will start automatically, and that it be running. We can check a lot with inspect. For another example, this site status rule is actually evaluating the content that's returned when we hit our server from the web. The HTTP resource here is going to be looking at the cart endpoint on localhost and validate whether we're getting a valid return code, 200, and whether the site body includes the text I expect, Planet Express. And with that, you can see here, my scan has failed. What's going on here? So, looks like it ran successfully against one of my nodes, and I have a sneaking suspicion of why the other one didn't work. And that suspicion is I didn't set up DNS properly. Pay no attention to the man behind the curtain as I go ahead and update a host file so that prod1 will actually resolve properly. Ultimately, though, my expectation when we run that scan against prod1 is that the scan will return a valid result, as mentioned earlier. Go ahead and re-add that node now that I've fixed my fake DNS. Same credentials, and we'll get to see some content there as soon as prod1 completes its scan. Always fun times on live demos. As we're going through this, though, some quick review on what it is that we're solving here. Each stage of this development style starts with this development cycle, starts with a problem we need to solve. Here the problem is that I need a way to validate whether or not my site is properly configured. By adding this inspect profile and starting to scan our systems, we have the ability to do that validation on demand, whether on existing systems or brand new ones that we create. Now, we can easily scan any system that we manage against these requirements and view the full comparative data in Chef Automate. And indeed, it was my DNS that was choking us. So here we see what I was expecting, one passed node and one failed node. If we take a look at that, we can see prod1 has passed all of the controls that I've defined, whereas my new Amazon instance has failed because we haven't actually configured any of this yet. And that's going to bring us to correct. In Chef, configuration changes are applied by a client that runs locally on each system that we manage. Installing that client and registering it with our Automate server is done via a process called bootstrapping. I've got a little script here that's going to be able to bootstrap one of our nodes. From there, we can apply an environment and run list to our server. So I'm going to bootstrap my dev1 server into the development environment. And that run list consists of recipes defined in Chef cookbooks. These recipes are what are responsible for applying the appropriate configurations to our nodes. In this case, my cookbook is called CMDemo, and the recipe is called site. Existing nodes can be bootstrapped over SSH or WinRM. So you can see here I'm using SSH to connect to our machine, and the command line tools in the Chef development kit will be able to handle the bootstrap process for us. Now, you'll notice I'm using my dev instance here because this process will apply changes to my systems. And I want to make sure that I test in dev before moving to more sensitive environments. Now, I could apply these same changes to that AWS instance we've already launched in much the same way by connecting over SSH and bootstrapping it. But one of the benefits of using Chef with AWS is that our tools integrate with their provisioning APIs, which allow us to create, bootstrap, and configure a new instance all in one step. So I'm going to create an AWS instance, also in my development environment, and I'm going to apply that same CMDemo cookbooks site recipe. Now, while we're waiting for that instance to be launched, we do have some data back from our dev1 instance. So we can take a look at how it's been configured via the nodes view in Chef Automate. I see now that I have a single node checking back and that its run was successful. If we dig in deeper, I can see that on this dev1 machine, those resources we mentioned earlier that live in our recipes consisted of 58 total configuration actions that needed to be taken. However, since our application was already installed on our system, you see that the vast majority of these resources, 47 of them, are listed as unchanged. This is because, as mentioned earlier, when Chef encounters a system that's already in its desired state, it doesn't take any action. It simply makes note of that and moves on to the next task. By contrast, we see that these 11 successful resources are those that took positive action during the run, or a change needed to be applied to bring our system in line with the desired state that we've defined. If there was an issue processing any of these resources, they'd instead show up in failed. When Chef encounters a failure, for example, say we ask Chef to install a package that doesn't exist, it will stop its run in place, leaving the remaining resources unprocessed. Automate will then provide us with a stack trace we can use to troubleshoot and remediate further. Now, if we take a look at our dev1 instance, we see our Planet Express app, but I saw Chef was taking some action on this run. So what did Chef actually do? Well, if I refresh here, we can see that our Chef recipe made a minor update to our site's content, identifying this as one of my on-premises systems. More on that in just a moment. Another thing that's worth noting, if we come back into compliance, you'll see now that there are 3 nodes showing up. And we have data for dev1, as well as the 2 nodes we scanned in our earlier step. Inspect scans can be triggered as part of a Chef client run, in addition to the agentless scanner we used earlier. What this means is that whenever we apply a new configuration to this dev1 system, we'll automatically get real-time insight into whether that change impacted our overall application health. Now we can see here my Amazon instance is doing a whole bunch of stuff in the background. And indeed, after bootstrapping, we can see those same resources that we saw in the Automate view getting applied here in the Chef client logs. I don't scroll down too far. Since this system is being built on a stock Ubuntu image, it has to do a little bit more. So the actual installation of Java and Tomcat, deployment of our database backups and site are all happening for the first time. Thankfully, I happen to know that this SSL recipe should be the last one that gets processed, and when this completes, we should have companion data for our AWS instance similar to what we saw on Dev 1. Restarting Tomcat, then it's going to run my audits. We should be ready to rock and roll. Hop back into the nodes view to preempt the changes I'm expecting. Can actually see here my Amazon instance is already showing up, and the rest of this data will be filled as soon as the run completes, which it looks like it just did. So I'll refresh my page here, and we see that our instance completed successfully. And just as before, I can view the details of our run. Now, note on this instance, there are still a few unchanged resources, since some tasks might already be configured even on a fairly bare image. However, a lot more is happening in our successful resources, and indeed, a vast majority of them needed to run since there is no pre-existing install of our application. As with Dev 1, we can now see our newly created Amazon instance in compliance as well and validate that it did indeed install our site in the manner we expect. Of course, the proof is in the pudding, so I can also grab this DNS name and pull up my site in a browser to validate that everything is indeed looking the way I expect it to. Since I'm using a self-signed cert, I get a little warning about that, the wonders of working in development. And indeed, I see my site, this time identifying itself as living on AWS. Now this is interesting. We applied the same recipes to both our Dev 1 instance and our new Amazon instance, but get different content on the resulting sites. How does that work? Well, I mentioned earlier that Chef is not only a repeatable process, but a dynamic one. And this is what we're seeing in play here. Since Chef represents our configuration as code, we have the ability to take conditional action based on a variety of inputs, including variables that we can configure directly, as well as profiling data that gets automatically captured every time a machine checks in with Chef. What that does is it provides us with the ability to configure similar but different environments without having to maintain a completely separate code base for each. And so, if we do that same process of reviewing the problems and our solutions here, in this correct step, our problem was that we needed to be able to deploy our application such that it meets the requirements we set forth in step 1. Because of our cloud integrations, we were able to very easily launch a new instance and configure it and bootstrap existing servers over commonly used network protocols. Because of the flexibility of Chef, even though there are minor differences in each environment's final configurations, I can satisfy them with a single Chef recipe. Because of that test and repair behavior, I can rerun the Chef client on a regular interval, and it will only apply changes that need to be applied, automatically remediating any drift or applying any new content as our automation evolves. And with that, now that we have our application deployed, the final task that we set forth was to be able to start getting a better idea of the security of our environments. For this, we're going to hop back into the compliance profile store. We have this Planet Express validator that I uploaded earlier, but we also have a library of predefined profiles that are available to us in Chef Automate. As mentioned, we have a number of CIS benchmark profiles, and since my machines are running Ubuntu 14.04, I'm going to go ahead and install the level 1 and level 2 benchmarks for that operating system. Right, installed level 1, next verse, same as the first, install level 2. Now you'll see, as with our validation profile, we can take a look at all of the controls defined within these CIS benchmarks. And in contrast to the profile I created, we can also see there's a lot more going on here. Instead of the, I think, 7 controls in my site validator, we've got a few hundred to process this time around. Now, even though I'm going to update our machines, and this time I'm going to update some existing machines in our development environment to append their run list with another recipe out of my CM demo cookbook, this one called CIS. This will go ahead and apply that to both of my development instances, Dev1 and this new cloud instance. And since the site has already been configured, I expect my nodes are going to take very little action outside of applying some extra inspect profiles when the run completes. That'll give us some new data in compliance that we can use to compare our on-prem system, which, as mentioned, has seen some ad hoc hardening in the past, and our Amazon instance, which we have not yet started taking any specific action to secure. Now, when this scan completes, I'll expect to see some failures on both systems, but I'll be able to get an idea of the delta between them. What configurations have been applied to secure my on-prem systems that have not yet been applied in the cloud. You can see, as before, Chef is going to give us some feedback into the action that it's taking, and we'll be able to review these in those same nodes and compliance views that we saw earlier. Chef client finished, that's always good. Let's see. I refresh. Both nodes checked in about a minute ago. All right, there we go. So if we hop into Dev1 here, refresh, so we got a new run. There we go. Wait for your run to complete before loading things, Nick. You can see, much like before, not a lot actually changing. Most of my resources are unchanged, but we do get a full run history. So we can compare that first run where it had to update my site content with this one where it had even less to do. Similarly, if we look at our Amazon instance, we see that it behaves much the same, since we took care of our heavy lifting on the previous run. If we take a closer look at this run history over here, what we'll also see is our first run took 3 minutes. It had a lot of changes to apply, where the other benefit of our test and repair process, not just saving us from redoing work, but the run only took a few seconds this time around, since it had far less to do. Of course, the fun part, take a look at the scan of our nodes. Now both Dev1 and our new instance are showing failures. However, it's worth noting that, as we expected, Dev1 is performing a little bit better. Since we have applied some hardening to it in the past, some of the security checks we're running are passing here with 131 failures, as opposed to the environment we haven't hardened at all, which has 149. As before, we can go ahead and review the scan results for everything that we've run and see just how they were applied to one system or the other. Now, the key takeaway here is we see a few hundred failures here, and that is a very scary prospect, but it shouldn't be. This is a very good thing for us. Why? Well, because we can't prioritize what we don't know. What we have now is a clear roadmap for what changes we'll need to make to our Amazon environment to bring it more in line with the hardening of our existing environments, and can see what remaining issues still need to be addressed across the board. These issues always existed on our systems. All we're doing now is actually looking at them and can determine whether or not individual fixes need to be prioritized and move forward with a clear plan of attack and a clear target to hit. And with that, I'm going to stop my screen share and bring us back into our deck here for a quick review of the automate step and tie things back to those outcomes we discussed at the very beginning of my presentation. This time around, now that we've identified a framework that we want to use and installed the associated profile, we immediately get feedback as to whether our systems are SIS compliant. As with previous automation, this gain is additive. In other words, now that I'm running these audits as part of every Chef client run on my development instances, I'll always know whether a future change is going to negatively impact my CIS compliance and can enter into formal audits with the confidence that my environment is consistently and auditably configured across the board. Now, to tie things back to those software success metrics that we talked about in the beginning, even with the limited work we've done today, we've made huge improvements on all three. For speed, well, now I can launch, configure, and audit new cloud instances on demand, the push of a button or the running of a CLI utility. As for efficiency, I can take care of per environment configuration differences dynamically by the same underlying recipe code, making sure that I'm A, not duplicating effort, and B, not introducing differences between those code bases if one half or another fails to get updated. And finally, as far as risk is concerned, every time that we configure these instances, we're also running a compliance scan. This provides us with real-time security data of every change that gets applied to my fleet before it hits production. And start these as early as development and shift compliance left to make sure that audits don't become an add-on to a production deploy, but something that everybody in my team can always maintain visibility into. And with that, I'd love to spend the remainder of this session answering some of your questions.
Great, thank you, Nick. We do have a bunch of questions coming in, but I encourage our audience to go ahead and submit any questions you may have to the Q&A box on the side of your screen. Let's dig in.
Yeah.
Okay, first question here, can I use Chef with Amazon auto-scaling?
Yeah, absolutely. So for folks that aren't familiar, Amazon has a feature called auto-scaling that we can use to define criteria for whether or not we need to scale different parts of our infrastructure. Say, if I have a lot of users hitting my site, I want to deploy new front-end machines automatically based on when load or user count or what have you is high. Now, Chef can be bootstrapped unattended, and we do have documentation for accomplishing that, in which case we can have those new auto-scaled instances automatically check in with Chef and apply whatever configuration is pertinent to that particular auto-scaling group.
Thank you.
No problem.
Our next question is, are the scripts available to us? Like for Bootstrap, AWS, Update, are those scripts available?
Yes. And so the short answer is yes. And for that, I'm going to quickly reshare my screen here and show kind of under the hood what I've been doing here. Just go ahead and make this full screen. So in order to kind of keep the presentation tight, I've abstracted some of Chef's commands a bit, so we can focus on what it is Chef is doing. On my system, I've done that with some PowerShell modules, and most of those are just wrapping our CLI utilities that are part of the Chef development kit. The project that I'm using here is an open source project, so some of these will actually be getting committed this week, but you can get a peek under the hood of what's happening here. One that might be of particular interest to us is this nice EC2 bootstrap that we did, where we can see when I created that, the actual command that's running in the background has some flags where we can define the type of Amazon instance we want to use, the security credentials and source image ID, security groups, etc. All of that cloud-specific information while being able to bootstrap and run our recipes on top of them.
Great, thanks, Nick.
No problem.
Let's see, can I use Terraform to define infrastructure and Chef Automate to manage them?
Absolutely. So Terraform, if folks aren't familiar, is a tool that I believe HashiCorp publishes. And as with a number of HashiCorp's tools, like Packer is an image building tool as well, there are integrations with Chef as well as with AWS. So it essentially provides us with a way to do a slightly more dynamic version of what you'll see native to AWS in CloudFormation. In either case, whether you're using native CloudFormation or Terraform, there is integration with Chef so that we can bootstrap and apply run lists the same way I was applying to systems in the demo here via our CLI utilities.
Excellent.
Yeah.
All right, if I'm using a built-in profile and want to ignore certain controls, can that be done without rewriting?
It sure can. So both inspect profiles and chef recipes are built with support for what we call wrapping. So in particular, let's say I look at these 131 failures and I decide that some of these actually aren't an issue to me. Either because that particular concern isn't huge, or I have an alternate method of validating that benchmark rule than what's provided in the profile. In those cases, we can actually create an inspect profile that wraps CIS, or we can say, pull in all of CIS's controls except for control X, Y, Z, et cetera, where we can do per profile exceptions, as well as the inverse, and say only execute these controls from said profile. With Chef, much the same is true of cookbooks. And if you saw in the background here, that CM demo cookbook was actually pulling in recipes from a number of different cookbooks so that I can apply a more complex set of tasks without having to create one all-encompassing cookbook to accommodate it.
Right, okay, thank you.
Yeah.
This next one is a great question. How is AWS OpsWorks different from Chef Automate? Yeah,
so in short, it isn't, I'm glad to say. It is a little bit different in how it's managed. So OpsWorks has a few different tools in it. The most recent being OpsWorks for Chef Automate, which is a way for you to deploy an AWS-managed Automate server. Similar to how we talked about the shared responsibility model and addressing your infrastructure, this makes the same be true of Chef, where Amazon will handle the updates of the system, the backups of the system, as well as optionally the licensing for Automate, while you are able to focus on just bootstrapping nodes and starting to get value out of this. So if you are interested in that, you can either have licensing handled through AWS or bring your own Automate license that you've gotten through us. Either will work with OpsWorks for Chef Automate, but ultimately it is the very same tool that you would deploy on premises or to your own server infrastructure.
All right.
Yeah.
So Nick, how does Chef handle the dynamic behavior you described? For example, the on-prem and on AWS text on the Planets page.
Yeah, good call. And actually for that, I'm actually going to take a quick look at that CM demo cookbook that we looked at earlier. Now, I'm happy to report that, let me actually get to the right folder first before I start talking, that there's not a whole lot of complex code to digest here. But we do have the ability to take some dynamic action. So if we actually take a look at this site recipe, you'll see that wrapping behavior that I mentioned earlier. It's including an audit recipe out of the same cookbook, as well as some configuration recipes out of a different cookbook. But it also has these attributes. This is where we define the variables that I mentioned earlier. For example, what I want to use to report my audits, which audits I'd like to run, and we can see here that I have an if-else block where I'm inspecting the FQDN of my systems, looking for the string compute.internal, that is the default DNS name for any of the AWS instances I launch. And based on what it gets back, it will either set the on AWS or on-prem text, respectively. There we go. And when it comes to that dynamic behavior, I mentioned that system profiling that happens. And if we actually take a look at, say, my Dev1 instance here or the Amazon instance that I launched, outside of resources, we have this attributes tab, which gives me a full hash of everything Chef knows about our system. Some of that are those variables that we defined. For example, which profiles are getting applied to that system, the Planets validator, and the CIS benchmarks. It also collects a bunch of auto-populating data, like my CPU information, memory, IP address, and on the case of Amazon instances, even a bunch of EC2 specific information. So if I wanted to be able to easily grab my public IP address, say, which can't be pulled out of ifconfig, I can pull it from this store and take dynamic action based on what I find.
Fantastic.
Yeah.
So we've got just enough time to handle one more question here.
Alrighty.
So how about updating version of an application on servers without downtime?
Yeah, so that without downtime is the trick, and it often is a matter of how the application itself is architected. Certain applications, as soon as we change some of the underlying content that might be statically defined or in a database, they are just updated. Others might require machine reboots or service restarts. So in those cases, we do have the ability to apply things and filter what we're applying based on things like environments, or if you're doing something like blue-green deployment, where you might have subsets of your infrastructure behind a load balancer, we would be able to parse those lists of nodes and apply changes conditionally, say, only to the pool of machines that are not behind the load balancer, and contingent on a successful run, we could add those machines and start running them on another set of machines. So ultimately, there's a lot of flexibility with what we can do here. And this is where, again, that kind of same idea of shared responsibility comes into play, but even with how you are working with a tool like Chef. Ultimately, you're going to be the person who knows your application best and what its requirements are going to be. We provide the tools to take that expertise and turn it into code that we can use to trigger on demand, regardless of whatever our specific needs might be.
All right, thank you, Nick, and thank you, Matt. We're just about out of time here. We would like to thank our audience for your live participation today. For those of you that submitted questions that we didn't have time to answer, we'll follow up with you via email and address those in the next week or so on the Chef blog, where we'll recap everything we covered here today. As a reminder, a copy of today's slide deck and additional help materials are available in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and bookmark any links that you might find useful. Of course, we hope you found value in the information that was presented today. If you like what you saw, we encourage you to share the recorded presentation with your teammates or professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. Thanks again for your time, and have a wonderful day.